to be here. I'm very aware that it's lunchtime in 1 minute, so I forgive you if you get grumpy with me. I'll try and keep it as short as possible. For the last 10 months since January, I've been based at Hluhluwe-iMfolozi Park, and I've been involved in the field-based monitoring of the elephant population there. And in this presentation, I just want to share some of the insights we got just in terms of the basic population information from the elephants and some of the tools we hope to develop to make for more efficient elephant monitoring going forwards. Before I steam ahead, just a brief outline on what I'll be talking about. I'll touch on a bit of context, elephants on the park and our project, and then I'll move on to the bulk of the talk, which is some baseline population information deriving from the monitoring this year. And then lastly, I will look ahead and share some of the ideas we have for more efficient elephant monitoring going forwards. I'm sure there's a lot of people in this room who know a bit more than I do about elephants on the park. Just a bit of a history. The trade for ivory was rampant during the 19th century. It decimated elephant populations in the province, Tembe being one of the few places where elephants remained consistently, if not the only place. And the last elephant was shot in the Hluhluwe-iMfolozi area in 1890 by the notorious colonial hunter John Donne. And then they were absent for 100 years until the then Natal Parks Board implemented a policy to reintroduce elephants. A total of 174 were introduced over that 15-year period. And they were 2 to 5 years old in age, and they originated from culling operations in Kruger. In 1991, the first calf was born, and then from that point onwards, the population has been growing quite steadily. Today, there's somewhere between 700 and 800, although our estimates are they're not very accurate. We're wanting to develop new methods for estimating the population. Linked to what Isaac was saying, there's concern over overpopulation. It's a closed system. There's fences. Elephants can't move away in drought and that sort of thing. There's localized impacts. And in response to this, management has been implementing an immunocontraception program to reduce birth rates. It's a medium to long-term solution. It doesn't reduce the population immediately. And just to give you an idea, last month, a total of 189 females were darted with the contraception. A bit about the project. On any reserve, it's important to monitor priority species in order to inform management. So in this case, it was elephants, and 17 adult females, mature adult females, are fitted with collars. And this is basically what I did during the first phase of the project, is track them using radio telemetry and collected information on their group sizes, their demography, the age and sex breakdowns, that sort of thing. With the main purpose of informing contraception and how it's carried out. In phase 2 of the project, which we hope to take forward next year, we identified 2 opportunities. The first, which is what I'll be presenting on today, the initial analysis of the population information. I was out there collecting lots of data, and there was lots of opportunities to analyze that. And then lastly, some novel monitoring tools, which I'll discuss at the end. Very briefly, monitoring was carried out by vehicle, and I tracked particular collared elephants. That was the basic strategy. And when I found a herd, I recorded a whole host of information, but perhaps the most important bits of information were group size estimates, ideas of the number of individuals in each age and size, age and sex category, and then photos. And what I did with the photos is Helene Druce, who was working on the park before me, and various monitors before her, compiled a database of positively identified elephants on the park, and I was able to match new photographs from the field to these. Important for various research purposes. That's the data, 72 monitoring outings. Very privileged to just be able to drive around the park and enjoy the elephants and other things. And most of the observations were of breeding herds. Those are the ones I was tracking. And the hashed lines in the blue bar represent the collared individual sightings. So there were a small proportion of elephants I came across just by chance and took information on them too. Fewer sightings of bulls and bull groups. So these are the 3 topics I'll be covering now. The first This figure represents the proportion of individuals in each of 4 age-size categories for breeding herds on the left of the dotted line. On the right of the dotted line is independent bulls. So that's the basic overall population demography. These are based on high-quality sightings, so I recorded how confident I was in my demographic breakdowns to produce this figure, 48 sightings. And as you can see, a quarter of the population, adult females, 20% independent bulls. This sort of information is useful. If you think of the infant proportions, we will see if those are going down in the next few years as the contraception takes effect. Proportion of adult females helps us generate targets for how many to target for contraception. And this is the main section of the results, the group sizes and variability. This shows basically the number of observations I made of elephants in each of those group size categories, focusing on breeding herds. This is the number of individuals excluding adult bulls. And as you can see, most of the time what I was seeing in breeding herds were small groups of less than 20 individuals in size. There's 2 ways to interpret this. Firstly, we could say that social units or herds on the park are stable, and you'd interpret this graph if you had that view, that there's just simply more smaller groups than there are bigger groups. And I just therefore came across those stable smaller groups more often. The alternative explanation is that elephants spend more time in smaller groups, but then they occasionally join up to form larger groups, and so it's a dynamic process of fission and fusion. To try and answer that, I'll just give you a bit more information about the collared elephants. Each is a mature adult female and part of its own family group of related adult females and their immature offspring. And I saw each one of these females a number of times. So we can look at what their group sizes were like. So there's the female IDs on the left, number of sightings for each one of them, and if you focus in on the ranges in the group sizes, they're very large, and the standard deviations of group sizes are large too. So basically what I was seeing is, at any one time seeing a particular elephant, her group size would be widely variable. Focusing in on one of the collared elephants, BH327, we see her group size distribution data matches that of the overall population. So she was seen 27 times across the park. And what this seems to suggest is that there is a dynamic fission process going on here, where BH327 is normally moving around with a small group of 10 to 20 individuals, but occasionally that small group pairs up with additional family groups. This is something that Leonard helped me understand, because he's got a lot of experience on Tembe, and he understands the social dynamics very much. And chatting with him was the first time I kind of began to understand what was happening on HIP. It's similar to Tembe. Just to show you that this holds true for an additional 5 elephants that were most commonly seen, this general pattern of seeing most commonly in small groups. To make sense of this, it'll be necessary to delve into a little bit of theory. Early behavioral studies, those mentioned there, kind of gave us the idea that elephant societies consist of a basic social unit of the family group, related adult females and their immature offspring. If we focus in now on the bottom part of the screen, these family groups may fission into smaller subgroups, or they may fuse into larger groups. And that's what's depicted in that figure there. And a bond group is 2 family groups that are seen together quite frequently. They'd be regarded as a bond group, because others are not seen together frequently. So there is some level of pattern in the associations. Just now with that lens, because I think that fission lens helps us make a lot of sense of the elephant sociality on the park. If we look at 327's family group or sightings, we see most of the time she's moving around with her core family group. Occasionally she's moving around with 2 to 3 additional families, and very occasionally probably around limited resources like water, moving in larger aggregations. So this figure here is the result of a social network analysis, and the nodes represent the collared adult females, 17 of them. And remember, each collared female actually represents a family group. I saw each one of them at least once with just their family and no other elephants present. But the lines represent connectedness between any two family groups. The thicker the line, the more frequently those two elephants were associated. So I think the take-home idea from this figure is just the loose dynamic structure of elephants on the park frequently associate amongst each other, fusion, fission, and it appears quite random, although you will see based on the thickness of the lines that there are some elephants that prefer to associate with certain other elephants and not others. So if we look at 87, she's been seen with a total of 9 other collared elephants on different occasions. And elephants like 355 and 140 have not been seen with any other collared elephant. Obviously, there are many uncollared family groups on the park, so what may be happening is that they're associating with groups that are uncollared. We hope to do a more in-depth social network analysis with the positive IDs. This was just easy in terms of the collared elephants. Let me just move past that one. Okay, just to finish off now, the last section, looking ahead to what we hope to do in 2017, funding dependent. We hope to develop these 3 tools for more efficient monitoring of elephant populations. We realize that they are a species of great management concern, and we hope that decisions on their management are based on the best possible information, and we hope that these tools, if we can expand them, develop them next year and then expand them to other reserves that could be used more widely. First, very quickly, photo ID system. You have a photo of an elephant from the field, you're not sure which one it is. You could work through the template file, it would take a lot of time. So we're trying to speed that process up where you label every identified elephant in the park according to its ID features. You say it's got a big notch on its right ear, it's got a hole at the bottom of its left ear, and its tusks are long and skew or something like that. Leonard's probably laughing now because the timber elephants have a notch all the way up their ears and there's no way of doing that. So it'll be a challenge for somewhere like that. But basically, when you've got your photo, you tick. This is an app that my cousin helped me develop, and you tick certain boxes saying this elephant that I've got a new photograph of has a big notch on the top of its right ear and it's missing its left tusk. You tick those boxes and then it gives you all the elephants in the database that match those features, and you can quickly search through them. And then this one I'm excited about, but very daunted by too. When I was studying in England, I met up with an amazing guy called Dr. Gopalaswamy, and he's developed models for estimating population sizes from mark recapture methods. And he's written the R software for it and whatnot. And I've been in touch with him saying, I've got this elephant data of sightings and resightings of positively identified individuals. Do you think that's amenable to this kind of analysis? And he's keen, he's willing to make it work. It remains to be seen what we can do, but I'm really hopeful we'll have a method for producing accurate population estimates of elephants on the park. And then finally, we want to create a data management system where this is again my cousin who's a computer science student is going to be helping me a lot, is developing an app, simple app, probably using existing systems that Jeff Klinning has developed for HIP for collecting elephant information, and then that app will feed into a central database of sightings, and in that database we'll add positively identified elephants, their photographs, their templates, their GPS data, and then hopefully we'll link up various analytical outputs, statistical analyses, GIS plugins, the population estimate model, the photo ID system, trying to link it all together into an integrated system that can be accessible and easy to use for managers, for those who are monitoring elephants. Basic idea is to develop this on HIP and hopefully expand it to other reserves. And yeah, so if that's relevant to you in any way, please come and speak to me, because we're keen to have maximum reach for this. At the end of the day, we want to ensure that elephant management is based on the best possible information. Thanks very much.